Today we are talking about equations in the real world. You have $50 to spend for an upcoming trip to Canobie Lake Park. It will cost you a $25 fee to enter the park and $5 per game that you want to play. How many games can you play? So our first step, we need to identify what it is we're trying to find. This is our variable. In this case, we're going to call it x. So what don't we know? Well, let's look at our question here. How many games can you play? So our x in this case is the number of games. Step 2, identify the important information in the problem. So what is important here? You have $50 to spend. Okay, so our total amount to spend is $50. It will cost you a $25 fee to enter. So just to get in the park, not even doing anything, it's going to cost us $25. And then $5 per game. $5 per game. Use the words in the problem to write an equation. So we have our fee to enter, which was $25, and plus $5 per game. This is going to change based on how many games we play. If we played one game, it would cost $5. Well, what if we wanted to play 2 games? We'd have to do our $5 per 2 games. So in this case, we're going to write it as 5x, right? X is the number of games that we're playing. This can change. And we have, in total, $50 to spend. This is the equation we would use to find how many games we can play. Now, if you wrote this backwards as 5x plus 25, the commutative property says that's okay. We would still get the same answer. So these are the same equation. Step 4, we want to solve the equation by isolating the variable. What does it mean to isolate? Isolate means we're going to get the variable by itself. So our first step, let's rewrite the equation. We had 25 plus 5x equal to the $50 we have in total to spend. Our first step is to remove the constant. Remember, the constant is the number by itself. We can go ahead and put our dotted line here. Our goal is to get x by itself or isolated. So we're going to start by removing the constant. This 25 has no negative in front of it, so it's a positive 25. What's the inverse or the opposite? We're going to subtract 25. Remember, whatever we do to one side of our balance, we have to do to the other side. If I did the inverse correctly, this should cancel out. So this is gone, it turned into 0. So we have 5x equals, well, 50 minus 25 is 25. My next step is to undo any multiplication or division using the inverse operation. If 5 and x are touching, that means multiplication. The inverse, or the opposite, is to divide. So I'm going to divide by 5 to isolate my variable. 5 divided by 5 is 1, so those would go away and leave me with just my x. Well, if I do it to one side of my balance, I have to do it to the other side. 25 divided by 5 is 5. So we get x equals 5. This means, in total, we could play 5 games. It's always good to go back to the question and make sure you're putting the correct label. If I said $5, that could potentially make my problem incorrect if it were multiple choice. So how many games can you play? Well, we can play 5 games.